This is a heat and temperature change problem. We will start with our heat is equal to our mass times the specific heat capacity times delta T. We're asked to calculate the final temperature. So we're going to first calculate delta T and add it to the initial temperature. So let's look at the values we need. We are given our heat in joules, and we're talking about silver, so we want the specific heat capacity of silver in joules. So we're going to be using 0.236 joules per gram degree C. So we have our specific heat capacity, we have our mass given to us here, and we're going to calculate our delta T. Okay, we're going to start at a temperature of 71 degrees C. We're adding heat to the system, so it's going to increase in temperature to some value TF. And our final temperature is going to be our initial temperature plus delta T. So we're going to solve this equation for delta T. And I didn't indicate it, but we are also given the value of heat. So let's start. We know that delta T is going to be our value of heat divided by our mass and specific heat capacity. So Q is 19 joules divided by our mass, 1.71 grams. And we're also going to divide by our heat capacity, 0.236 joules per gram degree C. We look at our units. We see that grams cancel and joules cancel. So the unit that survives is degrees C, which is good because we're trying to calculate a change in temperature. We put all these numbers into our calculator, and we get our calculator answer of 57.08 degrees C. We're not going to worry about sig figs until we have a final answer. So our TF is equal to TI plus delta T. That's going to be 71 degrees C plus 47.08 degrees C. This gives us 118.08 degrees C. Now we can go back and worry about our significant figures. We look at all the numbers that go into the result. 3 sig figs, 3 sig figs, 3 sig figs. So our delta T is good to 3 sig figs, which means when we add, we can use up to the 10th decimal place as far as this number is concerned. But when we add our values together and we look at our sig figs overall, we see this number is only good to the ones place. And even though this is good to the 10th place, we're not going to be able to report our answer to the 10th place because we're limited by this number here, which is only good to the ones place. So our answer can only be expressed to the ones place and is correctly written as 118 degrees C.